Well, let's get started with today's topic, which is comparison and logical operators. First of all, let's talk about logical operators. There are three logical operators in C Sharp, and these three operators will be of immense use to you. The first operator is the logical AND operator, which you can use by typing the ampersand symbol twice. When you use logical AND, all the conditions that you join using the double ampersand operator will have to be true for the code inside the conditional block to be executed. If even a single one of this condition was not met, then the code inside the conditional block will not be executed. Next is the logical OR operator, which can be used by typing the pipeline symbol twice. When you use logical OR, any one of the conditions that you join using the double pipeline operator will have to be true for the code inside the conditional block to be executed. If none of the conditions that you joined using the logical OR operator were met, then the code inside the conditional block will not be executed. And the last one is the logical NOT operator, which can be used by prefixing an exclamation mark to the equation. Logical NOT operator is used to reverse the output of any condition. So if the output of the condition returns true and you prefix the condition with the logical NOT operator, then the output will be reversed and will return false instead of true. With that done, let me give you an overview of the comparison operators, and then we can move on to the code, which will cover both logical and comparison operators in one go. As you can see, there are 6 comparison operators, and to be honest, I don't even need to go through them as they're pretty self-explanatory. But here goes. The first and the second operator, that is the equal to and not equal to operators, are used to check if the data contained inside a variable is equal to or not equal to another variable or a hard-coded string or a number or a boolean. Equal to will return true if the operands on both sides of the equation are the same, while not equal to will return true if the operands on both sides of the equation are different than each other. Next is the third and fourth operators, that is greater than and less than operators. These two operators are used to compare numbers to each other. Greater than will return true if the variable or number on the left side of the equation is greater than the number on the right side of the equation, while less than will return true if the variable or number on the left side of the equation is less than the number on the right side of the equation. Now the final two operators, that is greater than equal to and less than equal to. These two operators are almost identical to the greater than and less than operators, with the only difference being that they will also return true if the number or variable on the left side of the equation is the same as the number or variable on the right side of the equation. Well, that does it for the overview. Now let's go to the code and start using these operators. If you have been following along through the whole series, then you might remember that in the video about variables, I wrote a pseudocode-like comment while I was explaining booleans. Let's take that example again, as we would be able to cover both comparison and logical operators together using that example. Going back to the RPG analogy, the example went like this. Think about a town in the game, with the houses that the player can go in and out of during a certain period of time, let's say from 9 AM to 5 PM. You can use a boolean to set the state of the door, like private bull _ is door open equal to true. Now what you can do is, in the script that manages the game world time and day and night cycle, when the time hits 9 AM, you set _ is door open to true, and at 5 PM you set it to false. And in the script that allows the player to move in and out of the house, you use this boolean and create a condition which will allow the player to enter the house if _ is door open is true, and will not allow the player to enter the house if _ is door open is false. Now, we are not going to make a day and night cycle script right now. What we are going to do instead is hardcode the current game time so that we can test our logic. First of all, let's declare a boolean named _ is door open. Next, we'll declare _ current game hour and set it to 10. Then _ house opening hour and set it to 9. And finally, _ house closing hour and set it to 17. Here, I'm following the 24-hour day cycle, which means that the current game hour that we stored is 10 AM in the morning. which would let us enter the house. Now let's write the conditional that will maintain the state of the door. If underscore current game hour is greater than or equal to underscore house opening hour, and end underscore current game hour is less than underscore house closing hour, then set underscore is door open boolean to true, else set underscore is door open boolean to false. After that, if underscore door open equal to true, then debug.log the player entered the house. Else if underscore is door open is not equal to true, then debug.log the player was not allowed to enter the house. Else debug.log something went wrong. Now this piece of code can be divided into two parts. The first section evaluates whether to set the underscore is door open boolean to true or false based on what the current game hour is. Here we are using the comparison operators and logical AND to make a compound condition in which both the conditions need to be true to set the underscore is door open boolean to true. And the second section evaluates, based on the result of the first section, that whether the player will be allowed to enter the house or will be stopped from entering the house. If the underscore is door open boolean was set to true in the first section, then the player will be allowed to enter the house, otherwise he will be stopped from entering the house. Now let's go to Unity and check the logs. As you can see, it says the player entered the house. Back to the code. Now let's change the logical AND operator to logical OR operator like this, and set underscore current game hour to 8 in the morning. Now because we changed it like this, the first condition will not be met, as 8 is not greater than or equal to 9, while the second condition will be met, as 8 is still less than 17. This will still allow us to enter the if block, because although the first condition was not met, we have used the pipeline operator to join the two conditions, which means that only one of the conditions need to be true to enter the if block, and in this case it is the second condition. Now let's go to Unity and check the logs. As you can see, it says the player entered the house. Back to the code. Now let's surround the conditions in the if block like this, and prefix it with the logical NOT operator. By doing so, we will reverse the output from true to false, which means that we will not be allowed to enter the if block, and the compiler will move on to the else block and set the underscore is door open boolean to false, which means that when we go to Unity and check the logs, the log should say that the player is not allowed to enter the house. And as you can see, it says the player was not allowed to enter the house. Now, this piece of code is simple and is working fine, but just to be sure that you understand, you will not be hard coding the underscore house opening hour and underscore house closing hours variable like this when you are developing a legit project, because if you are making something like an RPG, you would have a lot of different kinds of shops and houses in your game, and your town people will have their own schedules that they would be following. So some shops will open at, let's say, 9 AM, while some might open at noon. Or maybe you have a night market in your game, which will only be functional at night. There will also be days where the shops will be closed because of a festival, or maybe because it's just a Sunday. The same goes when we are talking about townhouses, as if no one is home, you might want to close the door and not allow the player to enter the house. My point is that you should never hardcode this sort of things, and instead make a system based on your criteria that will manage this aspect of the game world for you in a way that is more modular and easy to manage. Another point to consider is that when you hardcode something like this, your game world will become more like a machine. That is, it will do things the same way at the same time and become too predictable and mechanical. While being predictable to a certain degree is necessary, but if your whole game is completely predictable, it will become stale pretty quickly. And the player will soon find that they are bored. And that is something that at least I, as a game developer, would not want my game to make the player feel. I'm not saying that things in your game can't follow a rigid schedule. For certain types of game, like factory simulators, it is extremely important that everything follows a certain rigid schedule. But what you need to do is add some unpredictability and variables to that otherwise monotonous game, like machines breaking down, workers going on riots, fire in the factory, crunch time leading to low productivity, and whatnot, to make your game more enjoyable and replayable for years. The more depth that you have in your game world's base systems, the more lived in your games will feel. And all in all, that's the whole point when you are designing a game. Making it so that the player can connect to the world like they are the part of the world and the NPCs in the world are real people, and not making the player feel like he or she is controlling a character, but instead making them feel like they are the characters themselves, is what you should try to do when you are developing a game. The more organic your world feels, and the more logically placed uncertainty and variables you have in your mechanics, the better your game will be, as the world we live in is an extremely complex system, and if you, as a game developer, are able to emulate even a small aspect of that sort of complexity in your game, then all I can say is kudos to you. Well, that does it for today's video. If you like the content, I hope that you will subscribe to the channel. I would love to hear your thoughts down in the comment section, and again, if you see someone struggling down in the comment section, do try and help them. Goodbye for now. This is your host VP signing off.